All right, guys, this is chapter 4, lesson 2. This is the second day of it. And the second day, what we're going to do is we still work on the horizontal shift and the vertical shift, except now as we're working on it, we're not just going to figure out what they are. We're actually going to make the graphs with it. And that's going to be a little bit trickier. It'll take a little more time here. And so now we're actually going to get the graphs. Before we begin, though, you want to make sure you know exactly what a sine graph looks like. You know these key points. I put it horizontally here in the table instead of vertically, but it's the same table. And you want to know in your head what that graph looks like, and hopefully you're not happy with my graph and thinking, shouldn't you have labeled pi halves and pi and 3 pi halves and 2 pi? And you are right, I should have. And the same thing with the cosine graph. Those should also be labeled with those same 4 key points. If you forget those are, don't worry, Ted always remembers them. So we've got those 4 key points. Pi halves, pi, 3 pi halves, 2 pi, labeled on the cosine graph as well. So you want to have those in your head. Now, we can do all sorts of things with these graphs. There's 4 different ways these can be shifted. And in a complicated graph, all 4 things will be going on, which is a big challenge. So if they ever put a number, remember, right in front of a trig function, that affects the amplitude, and that would affect the y-coordinates. You have to multiply your y-coordinates by 4. If they ever put a number in here with the x, that affects the period. You divided the you divided the x-coordinates by 4 when you had that. And in a complicated graph, you'll always do these 2 things first. If you think about order of operations, please excuse my dear Aunt Sally, you multiply or divide first before you add or subtract. So you'll consider the amplitude and period first. That's the way we learn these. That was section 1. Then we came down to section 2, which is the section we're in now. And you can handle the vertical shift. If they add something on, you would add that to the y-coordinates. And if they put something in here with the x, a minus pi fourths, that shifts your graph to the right pi fourths, you would add that to the x-coordinates. So we'll do the amplitude and period first, the vertical shift and phase shift second. So let's just look at this a little more specifically, and then we'll actually do a couple examples. So if all 4 things are going on here, you got a number in front, you got a number here with the x, you've got here with the x, and then you're adding something on at the end or at the beginning of this thing. So would you guys agree, I hope, that this number in front, this a, affects the amplitude? It is the amplitude, multiply the y-coordinate. The number in front of the x, this b, affects the period. That's when we divided all of the x-coordinates. So, and out of those 2, take your pick. Do those first, and you can, mix and match here between the 2. But those you need to do first. And then C and D, let's see. So C is the plus or minus here at the end. That would shift the graph up or down. So you'd add that to the y-coordinate. Then our D is the phase shift, which shifts the graph left to right. And whatever that is, remember that was the one that was opposite. So add the opposite to the x-coordinate. So those are the 4 things that can go on. If that seems a little confusing, just watch as we do the examples, and I think you'll find it not quite so confusing. All right, so let's try this. Here is a graph, or here's a function, y equals 3 plus 2 sine of x. And again, if I was doing these, I would begin right here with my chart. You know that chart for sine? Goes 0, 1, 0, negative 1, 0. So you got that sine graph in your head. And we see there's 2 things going on with our sine graph. This affects, you can fill in that blank, that affects the amplitude. And this added on to the front or the back is your vertical shift. So you might look back in your notes that we just gave here and say, okay, what am I going to do with these? Well, you do the amplitude first. And the amplitude, you're going to multiply the y-coordinates. And so maybe even here on your chart, you just cross these off and multiply the y-coordinates. I take them all times 2. So I cross these off. I'm going to multiply all these times 2. I get a 0, 2, 0, negative 2, 0. Not much to it. The vertical shift. What do we do with the vertical shift? It shifts it up or down. This is a 3, so I'm going to add 3. The vertical up or down is a y-coordinate, so I add 3 to the y-coordinates. But again, it's important that you multiply or divide first, add or subtract second. And so now I will add 3 to all the y-coordinates. So I've got all these. I'll cross them out again. Add on 3, I get a 3, and a 5, and a 3, and a 1, and a 3. Those are the only two numbers I had, so I'm ready to graph this. I will label my key points. Pi halves, pi, 3 pi halves, 2 pi. I'll look over here at my y-coordinates, and I'll see my biggest y-coordinate. I might just kind of sketch these over here. I'm going to erase that. There's 3, 5, 3, 1, 3. I'm going to erase that here if I can. Yeah, not too bad. And I see my largest y-coordinate is 5, so I think I want to count by ones on my scale, so I erase that and give myself a little more room. There's a 5, and a 4, and a 3, and a 2, and a 1. And I plot my points. When when x was 0, my y-coordinate was 3. Then it went up to 5. Then it's back to 3. Then it's to 1. And then it's to 3. I connect with a nice smooth curve. Look, guys, it's my same sine graph, but it was shifted up 3. So I can kind of see the middle of this graph is 3. And from there, the amplitude is 2. It goes down 2 or up 2. And that is my new graph. A little bit of work to get it, but it's kind of cool once you do. All right, let's try another example. We have 3 more examples. We'll see how many we can get through. Look at this. 3 different things going on. We've got a -1. Look back at your chart. That's the vertical shift. You're going to shift. We'll add or subtract that to the y-coordinates. So subtract 1 to the y-coordinates. We know we do not do that first because we know the order of operations. Here we've got a -2. That's the amplitude. We know we're going to multiply the y-coordinates. And then inside with the x, we've got this 3. That's going to affect the period. And what I'm going to do with that is I'm going to divide the x-coordinates by 3. Okay, amplitude and period come first. Look back in your notes. So let's just do this division right now and get it out of the way. That's the most difficult one. I'm going to divide by 3. How do I divide by 3? That's the same thing as multiplying by the reciprocal 1/3. And so we'll come here to the x-coordinates. We'll cross off what we have. We'll multiply by 1/3. And let's see. 0 times 1/3. Didn't really need to cross it off. Still 0. Pi halves times 1/3. So here's pi halves times 1/3. Multiply the tops. Multiply the bottoms. That now becomes pi 6. Pi times 1/3. Pi thirds. 3 pi halves. So put a 3 here. And I get 3 pi 6. Reduce that. That becomes pi halves. And 2 pi times 1/3. 2 pi thirds. So that takes care of my x-coordinates. My y-coordinates have to do 2 things. I have to multiply. I'll do that first. I multiply by -2. So I get a -2, and a 0, and a 2, and a 0, and a -2. And then I come over here and say, oh, wait a minute, it also has a vertical shift. I have to subtract 1. -2 minus 1, -3, -1, 1, -1, -3. So I've done 3 different things to this graph. Let's see what the final product looks like. Down here, my key points, I've got 0. Don't say pi halves, it was divided by 3. So it's pi 6, pi thirds, pi halves, 2 pi thirds. I look over here, I see I go from -3 to 1, so I can just count by ones. That's 3. That's -3. We plot our points at 0, we're at -3. Pi 6, we're at -1. Pi thirds, we are at 1. All right, yep. Pi halves, we're down to -1. And 2 pi thirds, we're back down to -3. Connect it again with a nice smooth curve. And we've got our graph. Again, you can kind of see the negative working its way in there. It flips over our cosine graph. We can see them, it's shifted down 1, so kind of the middle of our graph is now at -1. And you can see the amplitude is up 2 and down 2. And you can see that 3 is now occurring 3 times faster. So it would be possible for certain people to do all this in their head. I kind of like the chart. It seems to work for everybody. But if you're also able to do this all in your head, good for you. I would expect the y-axis to be labeled. I expect the x-axis to be labeled. And if you can do all that without the chart, even better. But past experience shows most people like to do these charts. Okay, I'd like to do just one more. I know you want to do both the examples here. Let's do one more. Let's look at this one. Oh my goodness. Let's do this one. It has all 4 things go. That's going to be a mess, actually. Let's do this one. This isn't not quite as messy. And I'll save the messy one. You can do that as it comes up in your homework. Or we'll probably take another day on this and just practice this. So let's do this one. Understanding with that pi thirds, I was avoiding the difficult fractions. And we'll stick with this one. All right. 3 things going on. We don't have an amplitude, do we? All right. So we do have a plus 2. That is our vertical shift. Hopefully now you got it. Add on to the y-coordinates. Add 2 to the y-coordinates. We've got this 2 here. It affects the period. We'll divide the x's by 2. We know it's the same as multiplying by 1/2. And then the plus pi fourths, we do the opposite. So we're going to subtract pi fourths from the x's. So the 2 in here with the x, they affect the x. The 2 on the outside affect the y. Okay, where do we begin? Order of operations, the division. So all the x's get divided by 2. Let's do that first. And again, how do I divide by 2? Same thing as multiplying by 1/2. First one is easy. Divide by 2. Still get 0. Here, pi halves divided by 2. Or pi halves times 1/2 is pi fourths. Hopefully that makes good sense to you. So I'm just going to cross it out, put a fourths. This will be pi halves. This will be 3 pi fourths. And here I divide it by 2. I get just a nice pi all by itself. All right, next. Let's take care of this pi fourths. From every x coordinate, I'm going to subtract pi fourths. Check your fractions on this a little bit. So I start with 0. 0 minus pi fourths is negative pi fourths. I need a little space here to write all this. Let me just take some of that out. So I've got a 0 minus pi fourths gives me negative pi fourths. It's going to shift the whole graph left pi fourths. Here, pi fourths minus pi fourths. That's my new 0. Pi halves minus pi fourths. And again, just neglect the pi for a minute. Just go 1/2 minus 1/4. You get a common denominator. 2/4 minus 1/4 is 1/4. You can throw back in the pi's now if you, oops, that was a funny looking pi. Put the pi back in, put the pi back in, put the pi back in, put the pi back in. So pi halves minus pi fourths is pi fourths, or 2/4 minus 1/4 is 1/4. With the pi's in here, we get pi fourths. At this point, you might see the pattern and say, I see what's going on here. It's going up by pi fourths. If not, subtract the next one. 3 pi fourths minus pi fourths. 3/4 minus 1/4 is 2/4. Reduce that, we get pi halves. And pi minus a fourth, a whole minus 1/4, leaves us 3 pi fourths. So that was the most work here, taking care of the x-coordinates. The y-coordinates, I add on the 2. So I get a 2, and a 3, and a 2, and a 1, and a 2. Plot my points. And again, this is non-negotiable. That's the origin. So negative pi fourths is here. Here's 0. Here's pi fourths. Here's pi halves. And here's 3 pi fourths. And actually, I kind of regret that choice of, I could have doubled this out, but we'll stay like that. And we will label our y-axis. We got a 1, 2, and a 3. We'll plot our points. And I've got at negative pi fourths, I've got a 2. At 0, I've got a 3. At pi fourths, I've got a 2. At pi, I've got a 1. I'm sorry, at pi halves, I've got a 1. And at 3 pi fourths, I've got a 2. Connect the dots. We get a nice smooth sine curve. Can you see it's shifted up 2? Look at the middle. Can you see it shifted to the left pi fourths? Yes, we can. Can we see it's occurring twice as frequently? Look, instead of 2 pi, the whole graph is occurring from negative pi fourths to 3 pi fourths. That's the length of pi. So this looks correct. And that completes our problems. I know you want to do the last one, but we'll wait on that one.